Hello, how are you? This is Abdul. So I just want to show you an example of the workflow, computational design, how I use it in my daily engineering work. So here I have the logic. Let me expand this. So this is the logic I've come up with. So basically at my work, we want to pass uh, black water pipes in the area between the foundation and the level 1 slab. But since this area is going to be filled with marram, so we want to anchor these pipes. So we are going to fabricate a pipe anchor. So basically we needed a design. Though the challenge was, since we are passing pipes of 75 mm diameter, 110, 160, 140, 300. So to come up with that design would take some time since we have different diameters of pipes, and also the anchorage depth is going to be different. So there's a lot of things going on. So because of this, uh, to appreciate the design and to come up with something good, all those different scenarios, I had to employ computational design. So as I said, so here is the logic. Let me turn on the preview. So this is the basic pipe anchor. So this area, this rod you see, so this is the one which is going to be in the marrow. So we expect the pipe to sit here. And then here we are planning to have a bolt or a nut to go through so that it can hold the pipe firm. So using this logic I've built, I am able, first of all, to change the width of this anchor to fit a specific pipe. So if I change this, now you see, if I have a bigger pipe, I just enlarge here, and also the bolt changes. The position of the bolt changes accordingly. You see, can make for thinner pipes, make the width smaller, and for bigger ones, I make it larger. You see, the anchorage rod remains always positioned at the center or at the centroid of the base. If I make this wide, it remains at the center, even if I make it smaller. Then I can also increase the height of our anchor, you see, make it shorter and bigger, and the bolt always remains also on the sides which will be holding the pipe tight, as you can see like this. Now we also have a fillet radius. Right now it is 4 radii. So I can make it a perfect U like this. When I increase the fillet radius, I make it a perfect U so that the pipe now sits directly, like the radius of the pipe sits like, I don't know how to explain, but the pipe just sits here. You see. Uh, if I make it smaller, then I have kind of like a box, a square, something, as you can see, something like that. So now it is 0. So if I increase it somewhere like that, so you can see. Can also have the sheet thickness. If we are going to house a smaller pipe of maybe 50 dia, then we don't need a thick sheet. But the more we go with the higher diameters, like maybe a 300 pipe, HDPE, high gauge, then also the thickness of the sheet has to be strong to hold the pipe intact. So here you can make the sheet bigger so that it can hold the pipe. So these numbers you see are in millimeters. So this is 6 millimeter sheet, 8, 9, can go all the way. But we agreed on 4. Now this is the depth. So the depth is how deep from this end to this end. I can make it smaller, as you can see. I can make the curtain small. Or I can make it bigger, as you can see, so that it holds a bigger surface area of the pipe. So this helped us in deciding the best anchor for the piping in that area without doing redesigning and what. Here we just change according to the need of a pipe, and also it is helping us to see uh, the effect of the thickness, of the depth, of the height on the stability of the pipe. Another good thing, if I decide, like when we have decided on the pipe, on on the anchor dimensions, we have very much different. Then I go to bake this into Rhino. Then if I turn this off, so you can see now this is the model we have. So I can go ahead to create a hole because I'm intending to use this one to create a hole. So if I go to Boolean difference, then I select this, select that. So this where we shall put the bolt or the nut so that I can hold the pipe in place. If I can export all this to AutoCAD for detailing. This first angle projection. Okay. So now opening AutoCAD. This is what I use for detailing to have the specific dimensions so that we can send it to the workshop for fabrication. So as you can see, this is the hole I talked about. So it is in first angle. So this is the plan, front end, and this is the this is the isometric drawing. So all my fillet is there, the thickness, don't remember the thickness we chose. But if I go to dimensions now, I can just come here and then start to do my dimensions. Yeah. So it's currently 122. inner wall diameter, inner wall length. So from this wall to this wall. So I can go on with other dimensions so that I just send it for dimension for publication. I, I think I'm going to do a longer video, which I think I'll post it on YouTube of how to come up with such logic. Because first you have to understand the process of what you're trying to make, and then you come up with the logic behind that. You get to see the constraints, and then you build a logic which follows those constraints, and then you can work around the design you are doing. Yeah.